Glad to be here. Thanks for inviting us. We wanted to give you a few glimpses of applying AI ML for the customer, for operations, and for good. Of course, along the way, we want to kind of weave in how it ties in with some of the H2O open source and some of the great tools as well. But before we do that, Shri started with a timeline. I think it went back to 2012. Let me just rewind a bit before 2012 and talk a little bit about AT&T and the history of AI ML as well. So you could go back all the way to the 1950s. That's where some of the early work out of AT&T was looking at programming a computer to play chess. And then in 1955, believe it or not, the first time artificial intelligence was coined was also AT&T collaborating with IBM, Harvard, and Dartmouth. And then in the 1970s, of course, we had huge innovations coming out of AT&T with Unix, C++, and then S, which ultimately turned into R that we know and love. So lots of development in the 70s. In the 80s and 90s, AT&T, Jan LeCun, who some of you may know, applied the first neural network to actually recognizing handwritten zip codes. And some of the foundational work in convolutional neural nets was done. And then in the 2000s, I would say it's a bit all about applying AI ML. But we also, in the early 2000s, Chris Valinsky from AT&T and my group actually won the Netflix recommender competition. And that was a $1 million hackathon. Don't see many of those on Kaggle, but great work there. And now we're all about applying AI in wireless, all of the media stuff, HBO Max, certainly the newest thing there, and then it's on fiber as well. So that's a bit of a timeline. Let me talk a little bit about some of our work and what are we doing to help on the same kind of AI workflow that Shri mentioned as well. For us, it kind of all starts with getting data, creating features, optimizing the AI, deploying the AI, and then of course, maintaining it or monitoring it afterwards. Each of these steps has various issues that I think the industry is addressing. One of the new developments in creating the features, in addition to some of the stuff that driverless AI does, is let's store those and share those. So we're working a lot on a machine learning feature store. Optimize AI has been really a powerhouse. If you think of the H2O, AutoML, and the open source tools, that's been super powerful. The driverless AI, which helps there immensely. All of those are highly used in our teams. In addition, we love the idea of really, I think Shri had it, is data as a team sport. And certainly AI is a team sport. So many times we try to do almost our own internal competitions. So hackathons. So we're deploying AI. We actually created our own internal tool, somewhat of an internal Kaggle, to do a leaderboard, right? So we want to get the best AI, and we'll take, H2O, driverless AI robots show up on the leaderboard, and then you try to improve on those as well. The new thing that is a great announcement here recently is the H2O wave, taking those great AI and turning those into AI first apps and kind of unlocking it for the business user. So we see a lot of benefit there. And then of course, I think we all have our own ways of not only monitoring, is the AI still good? Is it drifting? But everything around it, because many times our AI and real-time systems is just a piece of the puzzle. So you really need to monitor the whole operations of everything around it. And we go after that as well. So let me switch over and let's talk a little bit about applications. I think you saw Shri talk about fraud. And this is certainly in our industry and many others. If you just look at wireless mobility, it's like $1 billion issue in the industry, right? And it comes in a variety of forms. This is really a moving target, but many of the things is, gaming where, the no intent to pay and the fraudster, tries to get in and they don't pay, or identity theft, stuff that they take off the dark web or other ways of getting it and, masquerading as the user. And then, unlocking phones kind of in a way that we wouldn't like to see as well. So how do you detect all these things? Certainly there's lots of things going on. It's a moving target, but you want to apply rules and machine learning. And just to give you a little bit of illustration, this is a little bit of our journey. I'm showing you just kind of a 3-year picture here. And we used to start with kind of only rules, right? So everybody, when you look at these things, you can catch lots of things by just rules of thumb and things that you can catch there. But it really wasn't until we applied machine learning that we really started to take a dent out of the fraud. And here you're just looking at a 3-year view. So year 2, you can see there's 5 machine learning algorithms deployed here. And you can notice the fraud events are going down. So this is fraud events not stopped, and we're taking it down there. And then year 3, we had great success there with 5 algorithms. We're now up to 26, and it's kind of always growing there as well. But you can see how it's even lower there. Now, these algorithms happens to be, these are all actually deployed with either the H2 open source, driverless AI, or the great mojos that'll actually allow us to deploy these things. So this was a huge success story and actually, going after fraud itself there. So let me give you just another example. This is one that we actually also partnered with H2O, but one of the things that's important to AT&T that is also kind of using AI for good is, certainly we're interested in making sure that our network is up all the time, making sure that if there's a flood risk in any area, that we're moving equipment to higher ground. So we actually started on an initiative with Argonne National Labs sometime back, and I think we took the entire southeast region, and we tried to predict flooding. So looking at multiple years out. And when we partnered with Argonne, it started with a bunch of physicists and supercomputers to actually do this work. And Sri and I actually had a chance to get on a panel and talk about AI for good. And we said, well, maybe we can try to replicate what the physicists and supercomputers folks did with actual AI. Could we replicate the same thing that the physics was producing, but do it with AI and do it much faster? We only had 2 weeks for this actual panel we were going to sit on. So we got the team together. We started thinking about the problem. This is one way to look at it. So on the left there, if you saw that area of the square that I showed you on the previous slide, that was an actual area in North Carolina. And we said, well, that 2D, and if I think about time, time is like how often does it rain over every single day? That kind of looks like almost an image type problem, right? So you could think of like each one of those slices there as a different time. You have all of these points where rain could fall, and ultimately you're trying to predict the flooding at any given point. So how do we do this? Well, I mentioned that we always love to collaborate. We always find that, if you give any problem to one data scientist and you give it, multiply it out to many, at the end of the day, the ensemble of the result is the best. So we partnered with H2O. We also partnered with our own crowd, our internal crowd of data scientists, and we have hundreds of those. And we put it on our own collaboration platform. So this is where we do our leaderboards, and we actually compare results here. So what were the results? Interesting enough, as you would expect, this is looking at the, just the error. Of course, the lower error is the better in terms of how accurate you are. And, this is like multiple models. So think of these as parts on the leaderboard. The one on the right is the actual one that we wound up with. But as you would expect, geographical features are important, but also how often does it rain, as you would expect, is important. We started looking at a few days, but ultimately we found that going up to 8 weeks of rain actually was predictive, because you kind of think about it after the fact. It depends how saturated the ground is in terms of whether you're going to have flooding there. Now, the interesting thing, this is another way to look at it. So that was kind of the, the RMSE point of view, but you don't really know what that means until you look at it kind of visually. So on the left was the output of the physics model. And think of this almost like a heat map in terms of flooding correlation versus actual. And on the right is the output of the AI model. And this was done in 2 weeks, with us and our kind of our hackathon type thing. And you notice very close correlation with the actual physics model. In fact, the F1 score you can see is very high there. Now, one last way just to kind of look at this is this is a great video that H2O team actually put together. And you're looking at the correlation of the flooding of that area over time. The darker the red here is actually the highest correlation. And another way just to kind of confirm that the results actually worked. So anyway, I'd say back to kind of the AI vision, all the tools. We love the open source. We contribute a lot ourselves. We love the tools there. We love some of the driverless AI. We love the vision of turning stuff into AI first with apps. And it's been a great partnership, and we're excited to see what's coming out of H2O this year. Thanks.